We got 5.7, inverse of a function. We got part 1 today. We'll finish up part 2 tomorrow. Okay? Inverse of a function. Jumps right into an example. Writing a formula for the input of a function. Let f of x equal 2x plus 3. Letter A wants me to solve y equals f of x for x. What else, or what do we treat f of x like? Y. So I'm going to put y equals 2x plus 3. And letter A just wants us to solve this equation for x. So this is algebra 1 stuff right here. Solving this equation for x, trying to get x by itself, using our inverse operations. Let's see if we remember how to do that. What would be my first step to get x by itself? Oh, yikes. We haven't done this in a while, have we? What? Subtract the 3. Very good. In order to get x by itself, I need to get the term containing x by itself first. So I got to get rid of that 3 first. So subtract 3. Can I combine y and negative 3? Are they like terms?
No.
No, so how would I write it? Y minus 3 equals 2x. The term containing x is now by itself, so now I can worry about getting x by itself. How would I get rid of that 2 with the x?
Divide by 2.
Divide by 2 on both sides. So I get x equals y minus 3 over 2, and that would be me solving that equation for x. So there's letter A. We okay with that? Any confusion there? Like I said, that's algebra 1 stuff right there. Hopefully we're not confused on it. Okay, letter B says find the input when the output is negative 7. Well, which variable is always my input? Which variable is always my output?
X is input.
X is input, Y is my output. So it gives me a number for my output, or it gives me a number for what? My Y. So what do you think I'm going to do with that negative 7? Plug it in for Y. To be up here. And get an x value. We'll get x equals whatever number this equals. Does that make sense? So what's negative 7 minus 3? Negative 10. And then negative 10 divided by 2? Negative 5. So the input when the output is negative 7 is negative 5. And I finished example 1. Are there any questions on that? No? You okay? Believe it or not, we just found the inverse of this function. Wow. So, notice that these steps undo each other. Functions that undo each other are called inverse functions. In example 1, the one we just did, you can use the equation solved for x to write the inverse of f by switching the roles of x and y. So here was our original function, 2x plus 3. And we solved it for x to get x equals y minus 3 over 2, correct? If we switch the roles of x and y, or x and f of x, I'd get g of x equals x minus 3 over 2. Does everyone see that? So these two functions, f of x and g of x, are inverses of each other because they undo each other. Because inverse functions interchange the input and output values of the original function, does everyone agree that we swapped input and output values? Because we changed the roles of x and y? Does everyone agree with that? Since we interchanged the input and output values of the original function, our domain and range are also interchanged. So the domain of my original function is the range of my inverse function. The range of my inverse or my original function is the domain of my inverse function. Does that make sense? We switch the roles of x and y, which our domain is our set of x values, our range is our set of y values. So if we switch those, then our domain and range switch as well. Okay? Does that make sense? Okay. So are there any questions about this? So this is just showing that the domains and range switch. So, our blue function was our original function, f of x equals 2x plus 3. It's just a line. Slopes 2, y-intercepts 3. So here's the graph of f of x equals 2x plus 3. So here's my x values, and here's my y values. The x values is my domain, y values is my range. Here's our inverse function, g of x equals x minus 3 over 2. It's our red function. So we switch the roles of x and y, right? So our domain and range switch as well. So like I said, the domain of the original function becomes the range of the inverse function. The range of the original function becomes the domain of my inverse function. They flip. The graph of an inverse function is a reflection of the graph of the original function. Our line of reflection is y equals x. So does everyone see that our original function was reflected over this line of reflection to get our inverse? Everyone see that? And that happens because of the switching of the domain and range. So we have -2, -1 for our original function. If I switch those, that'd become -1, -2, right? So that's why it's reflected over y equals x. All of those are just going to flip. So, to find the inverse of a function algebraically, switch the roles of x and y and then solve for y. So take your original function, switch x and y, solve for y. That'll give you your inverse of your original function. Has everyone got that?
You're not speaking English.
Yeah, I am.
Plus it's like 6 hours.
We still got to pay attention. So, like I said, to find the inverse of a function, switch the roles of x and y. So switch them in the equation. Make yx, make xy, and I solve that equation for y. That'll give me my inverse of my original function. Okay? We're ready to look at an example. Find the inverse of f of x equals 3x minus 1. How do I find the inverse algebraically? Well, what did the last slide say?
Check numbers. Do you see this?
That's great, yeah. Switch the roles of x and y. Well, we treat f of x like y. So I'm literally just going to switch x and y. So it's going to become x equals 3y minus 1. And now what am I solving for? Huh? What am I solving for? Which variable?
X.
And solve for y.
Oh my.
So, inverse operations, back to Algebra 1 stuff. It's my first step to get y by itself. Add 1 to both sides. Can I combine x and 1? No, so I'd leave it as x plus 1 equals 3y. How would I get y by itself? Divide by 3. So I'd get y equals x plus 1 over 3. Now in my assignment, it might ask me to make the inverse function g of x or h of x. So I'm just going to call it g of x equals x plus 1 over 3. And there's my inverse. I'm done. Everyone got that? Yeah? You okay with that? That's my answer. We good? No questions on example 2? Okay, move on. Okay. There we go.
That was it? Oh.
Page 289, numbers 5 to 20 all.
Yeah, you owe me $40. Rocket science. 15 questions? You're crazy.
Page 289, numbers 5 to 20 all.
And we're supposed to.
So
What?
these are
So you gave us 2 examples, and we're supposed to understand that with 2 examples.
Well, that's just part 1 of 5.7.
so
We'll get part 2 tomorrow.
So we're supposed to understand that?
Yeah. All of those problems are based on the 2 examples we did.
No, I think your sheet.
Are there any questions about my recording before I end it?
Yeah.